All right, so we learned how to do this graphically. So now let's try to do this without using a graph. I mean, we're still going to use the graph to get an idea. So the first thing I'm going to do is I'm going to say 3x minus y equals 7. And I want to get y by itself, so I'm going to subtract 3x from both sides, because that's the only option I have to move the entire 3x over. Remembering that whatever I do on one side, I do to the other. 3x minus 3x is 0. That leaves me with negative y equals negative 3x plus 7. I don't want to solve for negative y. I want to solve for positive y. Remembering that if I take a negative and multiply it by a negative, I get a positive. So to get a positive y, I multiply by negative 1. Remember, whatever I do on one side, I do to the other. Negative 1 times negative 3x makes that a positive 3x. Negative 1 times positive 7 makes that a negative 7. Okay, cool. So now, to get to this other equation, I'm going to do the exact same thing, except, yes. Sure. So on this next one, I've got y plus 4 equals 2x plus 5 squared. Okay. So same thing. I want to get y by itself. So what do you guys think I should do? Minus 4. So I'm going to subtract 4 from both sides. By the way, even if you guess wrong, right? Like, what if you, well, multiply by 4. If you do the math, you'll know whether you're right or wrong. In other words, if I say 4 minus 4, well, let's say I say 4 times 4. 4 times 4 is 16. That doesn't go away. If I say 4 divided by 4, that leaves me with a positive 1. So I'd have y plus 1. So eventually you'll get the right answer. So always actually at this point do the actual math and see if you're right. But in this case, 4 minus 4 is 0. 0 plus y is y. And then for this, we're just going to leave it like this for now. Now, the next thing I'm going to do is I'm going to have to graph this on the graphing calculator. Okay? I'll just leave that up there for just a second so you guys can write that down. If you've already written it down, graph both equations in the graphing calculator and look to see where they intersect. Can I start plugging this in? All right. So go to y equals, and my first equation is going to have to be 3x, 3 times x minus 7. My second equation is 2 times the quantity x plus 5 squared. And what was the rest of that? It's minus 4 actually, right? 2x plus 5 squared minus 4. So that looks right. So I'm going to hit graph. What? It doesn't cross at all. Okay? It doesn't cross at all. Well, that's no bueno. Now, this can still be solved algebraically. The problem with solving this algebraically, and I'm a little bit flustered with the publisher of this textbook, is that they're never going to cross, so I'm not going to have a real solution. So if I look at this, what does that tell us about the solution? Yes. There's no real solution. So let's say that. So say no real. So that means we could still get a solution. It would just have to be imaginary numbers. Okay? So let's crank through some math. So I'm going to, if they're both equal to y, then I would say that 3x minus 7 is equal to 2 times the quantity x plus 5 squared minus 4. I'm just writing this equation here, which is set equal to y, and this is set equal to y. In other words, if they're both equal to y and they have a system and they have the same y value, they should equal each other. So I'm just taking those two things in the boxes and setting them equal to each other. Now I'm probably going to run out of space, but that's okay. So what I want to do is get everything on one side of the equal sign. This is a quadratic, so it'll probably look like ax squared plus bx plus c equals 0. So I'm going to, let's add 4 to both sides. Actually, no. Take that back. Let's add 7 to both sides. So if I add 7 to this side, I add 7 to this side, I get 3x is equal to 2 times the quantity x plus 5 squared. Negative 4 plus 7 is positive 3. I'm going to subtract 3x from both sides. And you'll say, what, Mr. Adams? Well, remember, we want it to look like, this always works best when we make it look like this. Ax squared plus bx plus c equals 0. That's what we want it to look like. So I'm just solving for 0. So this becomes 0, and then I have 2 times the quantity x plus 5 squared minus 3x plus 3. Now the problem here is I need to figure out what this squared is. So there is a pattern that you can, it should be x squared plus 10x plus 25. Mr. Adams has memorized that pattern. You guys may not have memorized, but I know that x plus 5 squared is the same as x plus 5 times the quantity x plus 5. What's x times x? 1x squared. What's 5 times x? Positive 5x. What's positive 5 times x? Positive 5x. And what's positive 5 times positive 5? Positive 25. So this whole thing in green is x squared plus 5x plus 5x plus 25. And actually, we need to multiply. Well, there's lots of stuff we got to do. And then we got to tack on this negative 3x and then plus 3. Okay. Well, the next step is to distribute the 2 through the parentheses. But what is, before I do that, what's 5x plus 5x? 10x. So I'm just going to make sure that I know that that's 10x. So 2 times x squared is 2x squared. 2 times 10x is a positive 20x. And then 2 times positive 25 is a positive 50. And then we have minus 3 plus 3x. I'm going to combine like terms. So I get 2x squared. The 20x plus 3 becomes positive 23x. Wait. Oh, you know what? I made a mistake. Did you guys see this mistake? This is supposed to be, well, hold on. Let me see. No, that's all right. Yeah, yeah, I see that. I saw that I made a mistake, but I kept getting the 3. This is where I was trying to figure out where I made my mistake. So this is a -3 and this is a +3. Thank you. Yeah, I saw it and I was like, wait a second, I missed something here. This is 17x. And then this is a positive 53. Okay. And all of that equals 0. So if I make this look like ax plus bx, ax squared plus bx plus c, then my a term is equal to 2. My b term is equal to 17. And my c term is equal to 53. Okay. All right. So now what do I do? Well, we get to use a quadratic formula. So to solve that goofy little thing, remember that x is equal to negative b plus or minus, and I'll zoom out. Did you guys have that other stuff written down, or do I need to zoom out so you can see it? Yeah, I'll zoom out. I'm in such a hurry trying to finish this before the bell rings. So let's zoom out like this. Make everything like this. Okay? So then I'm just going to take these values and plug them into the formula. In other words, x is equal to negative b, negative 17, plus or minus, bless you, 17 squared, minus 4 times a, which is times 2. Actually, I don't have enough room. I'm drawing too big. This is negative 17 plus or minus the square root of 17 squared minus 4 times 2 times c, which is 53. Woo, that's a big number. All over 2a, which is 2 times 2. Okay. So then the next line is going to be x equals negative 17 plus or minus the square root 17 squared. You guys know that off the top of your head? 289, obviously. Minus 4 times 2, which is negative 8, times 53 is 424. All over 2 times 2, which is 4. So then on the next line, I've got negative 17 plus or minus. When you do the math of these two numbers here, that's negative 135. All over 4. Now, can we take the square root of a negative number? No. So this is a complex solution. So we have, in other words, we'd have to have an imaginary number in there, right? Complex solution. How many? 2. Because you got the plus or minus. But it's there's no real solution. So whenever you get to a complex or imaginary number, just know that the graphs don't cross. Oh, that was a lot of work. How do you feel about that problem? Thumbs up if you love it. Thumbs down if you wanted to stay home today. Huh?